Hello everyone, my name is Nadya Syifa Azzahra, and before we dive into the topic, I want you to imagine something familiar. Picture yourself opening your favorite apps, maybe Amazon to check out of a flash sale, or Shopee for late night shopping, or even using Netflix to watch a series. Now, imagine if one day, during a huge sale, the checkout fails, or your payment keeps getting charged twice, or Netflix suddenly crashes in the middle of a new episode. In today's digital era, users expect apps to work flawlessly, instantly, and consistently. Even the smallest bug can spread across millions of users can cause major financial or reputational damage. This is why software testing and especially test management is absolutely essential. And within test management, two components stand at the heart of controlling quality: test monitoring and defect management. In this video, I will explain the concept of test management for monitoring and defect management, highlight the key point you need to know, and walk through a real-world example from an actual global company. Let's begin. To understand test monitoring, we first need to recognize that software projects rarely progress exactly as planned. Requirements shift, risks turn into real issues, environments break, and sometimes even items are delivered late. Because of this natural unpredictability, teams need a structured method to continuously observe what is happening during the testing process. This is now as test monitoring. Test monitoring involves gathering detailed and up-to-date information about test activities. It answers questions like how many test cases have been executed, are failures increasing or decreasing, are we still aligned with the test plan, has product quality improved since the last build. Monitoring helps provide clarity, visibility, and awareness so the team can understand whether they are moving towards exit criteria or falling behind schedule. However, observing alone is not enough. When monitoring reveals problems such as delays, resource shortage, or unexpectedly high defect rates, this is where test control comes into play. Test control is the process of making adjustment or corrective actions based on monitoring results. This may involve reprioritizing tasks, reallocating tester or developer, shifting deadlines, or modifying the test strategy entirely. Together, monitoring and control create a feedback loop that guides the testing effort toward the best possible outcome. One of the central elements of monitoring is the use of metrics. Metrics help transfer raw observation into measurable, meaningful insights. Common testing metrics include the percentage of test case prepared, executed, and passed, the number of defects detected each day, the failure rate, defect severity distribution, and the overall test coverage. Metrics help teams analyze progress, identify bottlenecks, and understand whether the product is stable or still risky. These metrics eventually fit into the test reports, which come into two major formats. First, the progress reports, generated during the testing phase to communicate current status, deviation from plan, and issues requiring decisions. Second, the summary reports, created at the end of a test level to evaluate whether the test objective and exit criteria were achieved. This report must be tailored to the audience. Executive usually needs a concise overview focusing on risk, costs, and timelines, while technical teams require more detailed data such as defect clusters, model quality trends, or unresolved issues. This leads us to defect management, which is another crucial aspect of test management. A defect is any deviation from an expected result during testing. Defect management ensures that every defect is properly recorded, categorized, assigned, tracked, and resolved. A good defect report contains essential elements such as reproduction step, severity, priority, actual versus expected results, related requirement, and the environment where the defect occurred. Defect management supports decision making by helping teams identify whether defects are rising or falling, whether certain models are unstable, and whether testing or development need more resources. In short, it ensures that defects are not only found but handled efficiently from start to finish. To see how this works in real life, look at an actual example from Amazon, one of the largest e-commerce platform in the world. Amazon processes millions of orders daily, and even a single defect in the checkout process can cause massive financial loss within minutes. During a major Prime Day update, Amazon introduced new features for promotion, multi-item discounting, and improved fraud detection. Because checkout is a business critical area, the testing team heavily relied on monitoring and defect management throughout the release cycle. The Amazon QA team used a real-time dashboard that track first daily execution rate of the test case, defect discovery and closure trend, performance indicator for checkout latency, risk-based coverage for key payment scenarios. Each morning, the dashboard will review in daily quality stand-up. If defect open curve rose sharply, the team immediately escalated the issues. Halfway through the testing period, monitoring revealed a problem. Defect closure was significantly behind schedule. Many medium severity defects were staying open for more than 5 days. Further spike in area related to coupon validation. Based on this monitoring insight, Amazon applied several control measures. Developers were reassigned temporarily to focus on only on payment-related defects. Testers shifted from writing new test cases to performing confirmation tests. A daily triage meeting was added to prioritize defect affecting revenue. Lower risk features had their testing postponed to free up resources. Amazon uses an internal defect tracking system integrated with their CI/CD pipeline. Every defect included full tracking information, reproduction step, screenshot, logs, timestamp, and link to user stories. When a developer pushed a fix, automated tests ran instantly, and testers received notification for retesting. During this cycle, the team discovered a major pricing rollback where certain promo codes incorrectly applied double discount under heavy load. Without monitoring and defect management, this could have caused millions in financial losses during Prime Day. Thanks to detailed monitoring and strong defect management, more than 97% of defects were closed before release. The number of new defects stabilized near the expected trend line. The checkout system went live smoothly during Prime Day. No critical incidents were reported in the first 40 hours of launch. This example from Amazon shows how essential monitoring and defect management are for maintaining product quality, especially for a system operating at global scale. In conclusion, monitoring and defect management are core pillars of effective test management. Monitoring helps teams understand progress and product quality in real time, while defect management ensures every issue is handled with accuracy and accountability. As seen in Amazon's real-world example, this practice can prevent large-scale failures, protect business revenue, and ensure users receive reliable, high-quality experience. Thank you for watching, and I hope this explanation has given you a clear understanding of how monitoring and defect management function in modern software testing. Thank you.